Here is number 20. All right, I did tell you that this is an arithmetic sequence, so the formula for this one is on your formula chart. Okay, that formula, same one as over here on number 21. S sub, we are trying to find how many terms are there between 1 and 40. Well, that's 40. So we're plugging that in as our n. 40 over 2. I don't know my first term, so I have to figure it out. To find my first term, you plug 1 into this rule. 3 times 1 is 3. Minus 1 gives you a 2. Your first term is 2. Plus, now I need to find my last term. So I'm plugging in 40. 3 times 40 is 120. 120 minus 1 is 119. Plug that in exactly as you see it to your calculator. And I got 2,420. All right, moving right along. This is a finite geometric sequence, okay? And from here, it told us 17 through 24, we're finding the sum. So I'm looking on my formula chart, and I'm finding the sum formula for a finite geometric sequence. That formula is, the sum is equal to a sub 1 times 1 minus r to the n power all over 1 minus r. So the three things that I need to have here in order to find the sum is my a sub 1, my r value, and my n value. We need to find those things. So, all right, a sub 1, I don't know what that is, but how would I find it? You always find a sub 1 by plugging 1 into your rule. So let's go, or no, actually, I'm sorry, for geometric sequences, this right here is your a sub 1. You don't have to do anything. I tell you your a sub 1. Okay, so a sub 1 is 3. 1 minus, my rate is always the thing inside the parentheses. So that's 1 minus 3 halves to the n power. Well, how many terms are there in between 1 and 5? That's 5. 1 over 3 halves. So put that into your calculator exactly as you see it. Here we go. 3 parenthesis alpha y equals 1. 1 minus, you can do a fraction. I'm just going to do 1.5 to the 5th power just to make it easier. 1 minus 1.5. Close. And I got 39 point, the instructions said to round to the 2 decimal places. So my final answer here is 39.56. Number 22, this is an infinite geometric sequence. So again, you do have a formula on your formula chart. Look at the last one. Again, this is my a sub 1. This is my r value. So the sum for an infinite geometric sequence is a sub 1 over 1 minus r. Plugging this in, a sub 1 is 4. 1 minus my r value is 1/3. Plug that in, let's see, that's 2/3. So this should be, what is that, 3 halves? 4 divided by 2/3. That should be, invert 2, that should be 6. Okay, 6. Over here, this is a finite geometric sequence. I'm still finding the sum. So this is exactly like number 21. I'm using this formula here. S sub, let's think really quickly, how many terms are there in between 1 and 100? Because I'm going from a 1 to a 0, that is 100 terms. So in, here, a sub 1, there's nothing in front of this. So looking at your formula chart, notice that it has a sub 1 times r, and r is the thing being raised to our exponent here. So this one's a little tricky. This value right here inside your parentheses is your r value. I don't see an a sub 1 there, so what would we have multiplied by that just wasn't shown? That's a 1. So your a sub 1 in this case is 1. If it's not shown, it's 1. So now let's plug it into this formula here. A sub 1 is 1. Then I have 1 minus my r value, but look here, my r value is negative. So you do need to say negative 1/2 to the 100th power all over 1 minus a negative 1/2. You do have to put in that minus a negative in order for this to work out correctly. So alpha y equals 1 minus negative 0.5 to the 100th all over 1 minus negative 0.5. And I got that. Let me triple check it in my calculator using the sum just to make sure. I don't want to tell you the wrong thing. Yes. Okay, I got 0.6 repeating, or that is 2/3. I'll take 0.6 repeating or 2/3. Again, just to make sure that I got it correct, I checked my work with Math 0. To get full credit on the test, you will need to show this work, but smart kids are going to check themselves in Math 0 to ensure that they get it correct. This is a finite geometric sequence, but this one is a little weird. Okay, this one is a little bit weird, so you're going to have to be careful here. In this case, what is n? A lot of you see n equals 151 and you assume that that's 151, but n is defined as the number of terms between your lower limit and your upper limit. So how many numbers are there going to be between 151 and 200? That is 50 terms. Okay, so be careful about that. So the sum is equal to, this is a finite, so we have an arithmetic, so this is your n over 2 a sub 1 plus a sub n. Be careful here. We're doing 50 terms. My first term, or my lower limit, is actually when I plug in my lower limit here. So negative 2 times 151 plus 1. My first term that I'm actually evaluating here is negative 301. Then I add that to my upper limit. If I plug in a 200 here, that's negative 400 plus a 1, that gives me negative 399. So now I'm going to plug that in as I see it. So this is 25 times negative 301 plus negative 399. So I got that this is negative 17,500. Again, I trust myself, but then question mark, maybe not. So I'm just going to triple check myself. Math 0, x going from 151 to 200 of negative 2n plus 1. Hallelujah. Okay, so I knew that my math was correct, but I still wanted to triple check. All right, finally, simplifying factorials. Okay, remember factorial 12. You will need to show your work, although smart kids are going to check themselves in the calculator. 12 factorial means you start with the number that you see, 12, subtract 1, subtract 1, subtract 1, until you get down to 1. Okay, I'm just going to put dot, 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 1, okay, because I'm running out of room. 10 factorial, you start with a 10, subtract 1, subtract 1, subtract 1, until you get down to 1. Okay, I could show all of those, but I think we all understand that the next one would be 6, and 5, and 4, and 3, and 2. You stop when you get to 1. Well, looking at this, I notice, well, these are going to cancel, and these, this whole last piece is going to cancel, and you're left with a 12 times 11, which is 132, question mark? 132, okay? Whew, brain's working a little slow. Okay, so I think as long as you'll have numbers, you're okay with it, but then your brain goes a little haywire when you have the ends. Okay, well, let's use this as a completely analogous problem. You saw 12 factorial and the very first number you wrote was a 12. Over here, I see n plus 1 factorial. The very first number I'm going to write is n plus 1. Over here, how did we get from 12 to 11? Well, we just subtracted 1. Here, if I subtract 1, I'm left with just an n. Then we subtracted another one. If I subtract another one from here, That's n minus 1. Subtract 1 again. And we did this process over and over again until we just got a 1. Over the bottom. You saw 10 factorial, the very first number you put was a 10. Here I see n minus 1 factorial. The first number I'm going to put is n minus 1. Well, from 10 we went down 1 to 9. If I go down 1, that's going to get me to n minus 2. If I go down 1 again, that's going to get me n minus 3 until I get to a 1. Same thing over here. We saw a 10 here and here, a 9 here and here, and we canceled them out. Look here, I see an n minus 1 and an n minus 1, n minus 2, n minus 2. From here over, these are going to cancel. And you're just left with n plus 1 times n. Or you can also write that as distributing n squared plus n. I'll take either one of those. Miss Cleveland, how could I double check myself to make sure that those are correct? Well, really quickly, putting something in the calculator, okay, alpha y equals 1 to get a fraction. 12, to get to factorial, you hit math, left arrow, 4. On the bottom 10, math, left arrow, 4. We got 132, so I know that this is correct. Well, Miss Cleveland, you told me I couldn't put ones like this in because they're not numbers. You can't put them in exactly. Okay, you can't put them in exactly, but you can triple check your work. Think of any number. Okay, let's see here. Nicholas, what's your favorite number? Any number. A bigger favorite number. 13. Okay. Let's say that we're just checking our work here. This is an example. Let's say that n is 13 in this problem. Okay. Well, if I plug this in, 13 plus 1 is going to give me 14 factorial. And then 13 minus 1 is going to give me 12 factorial. Okay. I can do that into my calculator really quickly. Okay, so here we go. 14 factorial over 12 factorial. I get 182. Okay? Well, now I'm going to plug that in and see if I get exactly the same thing. Over here, my n was 13, so 13 squared plus 13. Those match. So I've got an example that proves that I'm right. So you can pick a number. You can't put the n's in your calculator, but you can choose a random n and figure out what that would be. All right, final ones. I would really make sure that I understood this because, you know, there could be one like this on the test. JS, just saying. All right, a radio contest gives the first 9 callers. What information does that give us? N. A cash prize. The first caller gets $1,000. What does that tell us? What does that give us? Your initial term. That's your first term. The second caller gets $950, the third caller gets $900, and so on. So what would my common difference be? How am I going just to 50? Minus 50. So be careful about that. It's going down 50. All right, so find the arithmetic sequence A sub n that represents the cash price awarded. When I say A sub n and the arithmetic sequence, I'm just wanting you to write a formula that is on your formula chart. A sub n is equal to your first term plus n minus 1 times the d. Okay? Yeah. So here, A sub n is equal to my first term, which is $1,000, plus n minus 1 times my common difference of negative 50. If you leave it like this, you will get partial credit, but I do want to see it multiplied out. So here, distribute. A sub n is equal to 1,000. If I distribute that, that's going to give me minus 50 n. And a negative 1 times a negative 50 gives me a positive 50. Combine these like terms here. And my general A sub n formula is negative 50n plus 1,050. That's all I'm looking for when I'm asking you to find the arithmetic sequence A sub n. You don't know what n is, so just leave n alone. Over here, though, I want the total prize money awarded. What am I actually asking for there? Adding them all up, and what is that called? The sum. So you need to be looking at your arithmetic sum formula. Well, that arithmetic sum formula, S sub n, is equal to n over 2 A sub 1 plus A sub n. Do we know n? What? Right, I told you that up here. That's your 9. You're giving out 9 prizes. I know my A sub 1 is 1,000. How could I find my A sub n? Plug in 9, right? We're giving out 9 prizes. The last prize is going to be a 9. So here we go. I'm giving out 9 total prizes. My first term I know is 1,000, plus I need to figure out what my last term will be using my general formula here. So negative 50 times 9, that is negative 450. Negative 450 plus 1050, is that 600? 600. You can prove that to yourself in just a moment. So plug that into my calculator. 4.5 times 1,600. And I get 7,200 as my final amount of money that I will eventually give out over the course of this contest. All right, study your 11.1, 11.2, 11.3 notes. Make sure you understand every question on this review, because my review is exactly like my test. Good luck.